We're splitting section 8 into 2 days. So day 1 we're writing linear equations. So by the end of this lesson you'll be able to write linear equations given the slope and the y-intercept, and you'll also be able to graph them. So in the first example I ask you to write the equation in slope-intercept form if I give you the slope and the y-intercept, and then I also would like the equation to be graphed. So let's remember that slope-intercept form is y equals mx plus b. And in the first example, I'm giving you m and I'm giving you b. So we're simply going to plug those two values into the equation. So plugging in 1/2 for m and -5 for b gives you y equals 1/2 x minus 5. Recognize that if the b term is negative, you're plugging in a -5, that's going to change that addition sign to subtraction. So here we have the equation in slope-intercept form, and now we want to graph it. When we graph an equation in slope-intercept form, we always start at the y-intercept. Remember that the y-intercept, and let me use my highlighter here, the y-intercept is the same as the b, so it's this -5, or the subtracting 5 that's in the back of the equation. That's your y-intercept. That's where you want to start. So when you graph your equation, if it has a y-intercept of -5, remember that means it goes through the y-axis at -5. That's what y-intercept means. So from here, we're going to use the slope of the line. Remember that on a line, the slope is constant. So here it's a positive 1/2. So from the y-intercept, remember 1/2, that's rise over run. And this is kind of backwards from the day when I would give you a line and ask you to find the slope, where you would count up, over, up, over. Now we're going to use that to get us to our next point. When we graph equations, I want 5 points. I want the y-intercept as point 1, and I want 2 points in each direction. So if this slope is positive 1/2, that means I'm going up 1 and over 2, up 1 and over 2. Now I can continue that pattern across the graph till I run out of room, and I also want you going in the other direction. So now down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, and down 1 over 2. Notice that I extend my line all the way across the graph, which is what I would like you to do. So I'm going to change my last point when I said I need 5 points on the line. I actually want every point on the line that's going to fit on that graph. So keep going until you run out of room in both directions. Now because the slope is positive, I look at my line, I'm just making sure, yes, I did go in the correct direction. I went in the positive direction. So we've written the equation in slope-intercept form, and we've graphed it. Example 2, I have a slope of -2. So that's y equals -2x, and my y-intercept is positive 3. So y equals -2x plus 3. Remember, we always start at the y-intercept, so that's up at positive 3. That means the graph of this line will go through the y-intercept at 3. And now I look at my slope. My slope is a -2, but I want it in a fraction so that I can see how many do I rise and how many do I run. So I'm going to go up 2 over 1, up 2 over 1 to get myself from one point to the next. I'm also recognizing that in this example, my slope is negative, which means when I go up, I need to go to the left so that my slope, my line, goes in this direction. So that's up 2 over 1, up 2 over 1, up 2 over 1, and now I'm out of graph to go up 2 again, so I'm going to go in the other direction. Down 2, now I do need to go to the right, down 2 in order to make a straight line. And I'm going to continue that pattern again until I run out of graph. So this is a fairly simple way to graph an equation of a line. We're not having to use a table of values, we're just using the slope and the y-intercept. And I think this is much simpler than a table of values. Okay, example 3, we have the slope of 0 and a y-intercept of -3/5. So when I plot this out, or when I write the equation, I have y equals, my slope is 0, so that's 0x. My y-intercept is a -3/5. So y equals 0x minus 3/5. Don't panic because it's a fraction. Just do your best to figure out where is -3/5. Okay, that's somewhere in between 0 and -1, and just make your best guess as to where that occurs. Now, my slope, again, it's the number in front of x. My slope is 0. So if I think for a moment, well, I could write 0 as a fraction and put it over 1. Or if you just remember that a line with 0 slope is horizontal, that's what your graph would look like. So it crosses the y-axis at -3/5, and it has 0 slope, so it's a horizontal line. Number 4, I have b equals 0 and m equals -1. So be careful here. I've kind of switched the order. So y equals, again, it's mx plus b. So here's my m is a -1, and you can write -1 or you can just write -x. It's your choice. And then my y-intercept is 0. You can write plus 0 back here, or you don't have to write anything at all. But you have to be able to recognize that that means that the graph is going to cross the y-axis at the origin, or where the y is 0. That's 0 on the y-axis at the origin. And now my slope again is -1. So if I want to write that like a fraction, I need to say -1 over 1, which means I'm going up 1 over 1, up 1 over 1, up 1 over 1, and I'm going to go all the way across the graph like this. Notice the direction I'm headed is so that my line has negative slope. So I'm going up and to the left or down and to the right. And I want you going all the way across the graph like this. So here's a line that crosses the origin or has a y-intercept of 0 and a slope of -1. So we looked at several examples today. Given the slope and the y-intercept, we're writing the equation first, and then we are graphing it. If you have questions, please make sure that you're asking in class, and we'll work on worksheet 8.8a.